Hi, lovers of mathematics. Here we are with another installment of Mr. Sivadas, an installment of mathematics, and we're going to start with simplifying. We're in Identities Part 2. We'll look at these and see if we can simplify them. Actually, I think I'll start with this second one here. If I see something and I don't see how I can relate it to anything like sine squared plus cosine squared equals 1 or those type, if in doubt, always make it into sines and cosines. So I'm going to do that. The secant of x is 1 over the cosine x minus the cosine x all over the tangent is the sine x over the cosine x. Well, notice how it would be nice to get rid of these cosines. So just working with regular fractions, I can multiply top and bottom by the cosine of x and the cosine of x. See, who said math was about numbers, right? So I'm going to distribute this to both of these, and I have cosine x over the cosine x minus the cosine squared x all over the sine x. So in other words, this cancels with this. This becomes the cosine squared, and this is the cosine over the cosine. Well, that's just 1. So this is 1 minus the cosine squared x over the sine of x. Well, we already know that 1 equals the sine squared plus the cosine squared, so let's put it in here, replace that 1. This is equal to the sine squared x plus the cosine squared x minus the cosine x all over the sine x. So all I did is I took this one, I just substituted sine squared plus cosine squared here. That's all I did here. We have a square on this one. And this is kind of nice because now we see these two, a positive and negative, cancel. All we have is the sine squared x over the sine of x, and that reduces to the sine of x. So that's all this is. It reduces to the sine of x. All right, let's try this one. Now this one, we could write this as a cosine over sine, and write this as, negative the cosine over the sine. No, negative the sine over the cosine. But we have different denominators there. So I don't like turning this into sines and cosines. But notice if I multiply this by the cotangent, I will get a cotangent. And a cotangent times the tangent is just 1 because they're inverses. I think I can get that top up here. So let's multiply everything by the cotangent of A. Cotangent of A times cotangent A minus 1 all over cotangent A times 1. Now, the tangent of negative A, this is odd, right? So this is, what's that? Oh, yeah. Cotangent of A minus the tangent of A. So this minus comes out because it's odd. Okay, so I'm going to leave the top alone because I think I can get this down here. When I multiply, I have just on the bottom, leave the top alone, the cotangent of A minus 1 all over. So I multiply this, I'm going to distribute this. I have the cotangent A minus the cotangent A tangent A. Now, the cotangent of A times the tangent of A is 1. we can put another step in there if we want, but if we take the cotangent of A times the tangent of A, I'm leaving the negative off for now just to show you this. The cotangent, let's put cotangent underneath. This is the tangent of A all over. The cotangent is 1 over the tangent. So that's just 1. So what I have here is the cotangent of A times the cotangent of A minus 1 all over the cotangent of A minus 1. Now look at this. Isn't this nice? These cancel, and you get the cotangent of A. So this reduces to the cotangent of A. Now, I don't want to oversimplify this. This takes a lot of thought. You have to play with these. These are puzzles. I'm going a little fast, but you can stop and look at it as you go along. And you could have done it with sines and cosines, I think. There's a number of different ways to do that. I just noticed that it would work nice if we multiply by the cotangent of A. So now we simplify these. Now what we're going to do on the next board is we're going to look at proofs. We're actually proving something. We want to prove that this equals 1. Since I don't see sine squared plus cosine squared equals 1 or anything like that, I think I'll turn these all into sines and cosines and work with it that way. So the cotangent, well, that's the cosine x over the sine x. And the secant is 1 over cosine x. And the cosecant is 1 over the sine x. Okay, we've made it all into sines and cosines. Look at how nice this is. This on top cancels with this. We have 1 over the sine x divided by 1 over the sine x. And when you divide the same on top and bottom, you get 1. So we just proved this is true, that this equals 1. Okay, let's look at this second one here. Well, what I notice is, this reminds me of x squared minus 1, and this is like x plus 1. And we know the difference of two squares, x squared minus 1 times x plus, is equal x plus 1 times x minus 1. So I see the difference of two squares. That's what I see here. So let's write that as the difference of two squares. This is the secant squared x plus the tangent squared x times the secant, the secant squared x minus the tangent squared x. So I'm just treating it as the difference of two squares, except we're using the fourth power, so this is what we get. Now, the secant squared is equal 1 plus the tangent squared. So let's replace that right here. This is 1 plus the tangent squared x, and we're subtracting a tangent squared x. And we have over here the secant squared x plus the tangent squared x. And look at how nice this is. The tangent squared minus the tangent squared is 1. 1 times this is just what we're trying to prove here. So we proved it. So again, I don't want to make this look too simple. This takes some thinking and takes some practice to get good at this. All right, we'll see you in the next video.